Hey, third graders. Okay, here we are for our second lesson of the first week of distance learning. So hopefully the first video was helpful to you. The second one is a little bit more challenging, so we'll work through it together and make sure you pause the video if you're getting overwhelmed and jot down any questions that you may have. And just like the last one, at the end of this, you will go back to the assignment on Google Classroom and you will fill out the form, which is your practice problems. Okay, so let's get started. So today's lesson, you will be solving word problems with unknown factors, okay? And you will also, so there's two parts to this one, we're going to review two things. And you can also solve word problems with unknown starts. All right, so let's look at the first one. These are vocabulary words that you're going to be using in this lesson. We're going to look at unknown factors, product, variable, which we learned about in the first lesson, and unknown starts, okay? So remember that when we see the multiplication sign, that means groups of, right? So when we had like 3 times 6, for example, that was saying 3 groups of 6 equals 18, right? So we could draw it as 3 groups of 6, okay? It also can mean rows of or columns of, right? But when we're multiplying, we're using equal groups. That means there's the same amount in each group, okay? So yesterday we worked with addend plus an addend equals your total. I'm not going to write all that out. That takes too long. Addend plus addend equals total. You guys can laugh at my terrible mouse drawing skills. Today we're going to look more at factor times a factor gives us the product, okay? So factor is the two numbers you're multiplying. So for this example, one factor is 3, the other factor is 6, and that gives us our product or our total, which is 18. Okay, so let's keep going. So let's practice some of these word problems where we have unknown factors. All right, Zoe has 36 boxes of stuffed animals to ship to 4 toy stores. Each toy store will get the same amount of boxes. How many boxes will each toy store get? So you're probably wondering, Ms. Cook, how do I know the difference if I'm going to add, subtract, multiply, or divide in these ones? So when we're multiplying and dividing, remember we're working with equal groups, right? We're breaking things apart in equal groups is when we're dividing, or when we're multiplying, we have groups of something. When we're adding and subtracting, we're either taking away or adding to. But with this one, we have equal groups. So this one I know I'm multiplying or dividing because I have equal groups because it says each toy store will get the same amount. So if I drew a picture, I've got my 4 toy stores. Aren't they lovely? 4 toy stores, and each one is getting the same amount of boxes. And I have 36 boxes to break evenly across 4 toy stores, okay? So I could do this, remember when we first were learning multiplication division, we drew pictures like this. I could break it apart and divvy out those 36 boxes. I could go 1 box will go here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And I could keep going until I get 36 boxes split up, okay? But since we've been practicing multiplication and division for a while, let's think about how we could write this into a multiplication or division word problem, or equation, so that we wouldn't have to draw the picture out. If you want to draw the picture, that's perfect, okay? So let's ask ourselves, do I know the total amount that we're looking for? I do. I know that there's 36 boxes in all, and they're getting broken apart into 4 different toys, okay? So if I start with my total, remember when we divide, it's just like subtracting. We always have to start with our total. I'm going to divide it or break it apart into 4 different stores. So those 36 boxes are getting divided into 4 stores, and I need to find out how many are going to each store, okay? And I'm going to put B for boxes, okay? 36 divided by 4 equals B. Now remember, in division, we can rewrite that as a multiplication problem. I could rewrite that. These are my 2 factors, right? And here's my total or my product. I could rewrite it as 4 groups of, right? I have 4 groups, 1, 2, 3, 4 groups of something will give me 36 in all, okay? We've been practicing our math facts a lot lately, so hopefully you have this down pat in your head, or you can sing the song that we've been practicing over the last couple of months, okay? Or if you need to, draw the picture, right? I went 12, 13, 14, 15, 16. I could keep going until I get to 36. But if I know my facts, 4 times 9 is 36. Okay, so B equals 9. Each store will get 9 boxes. So there's 9 here, 9 here, 9 here, and 9 here. And you can check your answer always by saying 9 times 4. Well, if we do use our 9s trick, right, put down your 4th finger, okay, and you've got 36. Try to get in front of the camera. There we go. 36. Okay. So each store got 9 boxes. Okay, hopefully that wasn't too confusing. If it was, you can always rewatch that part. But we're going to keep practicing. We'll do something just like it. Okay. There are 56 cars in Chris's parking lot. There are 8 rows and the same number of cars in each row. How many cars are in each row? Okay, so there's 56 cars in all, and they're divided into 8 different rows, right? So we know that we're multiplying and dividing here because there's the same number of cars in each row, right? They're equal groups, okay? It's not saying there's 56 cars and 8 drove away, right? That'd be subtracting. Or it's not saying there's 56 cars in this parking lot and 8 in the other one. How many in all? Okay, that would be adding. It's saying that there's 56 in all, and they're broken apart into groups of 8. Or there's 8 groups, right? So if we start with our total, we've got 56 cars in all, and I'm going to break them apart into 8 rows. 56 divided by 8 equals something. So I'm going to put a C for cars, okay? 56 divided by 8 equals C. Another way I could write this, which I know a lot of you are way more comfortable with multiplication than you are division, is you could say 8 times something will give me 56. Okay? If you want to sing your 8 song, whatever it does to help you, okay? And another way you could do this also is you could draw 8 groups, right? 8 rows or 8 groups or whatever. And you could divvy out those 56 cars. Now, will that take a while? Yes. That's why it's so important that you're practicing your math facts so you don't have to do these pictures that take a long time. If you need to do those pictures, though, do them, okay? Whatever helps you to get the answer. 8 times something equals 56. What is 8 times? 8 times what? 8 times 7, right? 5, 6, 7, 8, 56 is 7 times 8, right? Remember our rhyme? Okay, so there's 7 cars in each row. Okay? Again, if you get overwhelmed or you are like, I would never be able to figure that out on my own, pause it. You can rewatch it, but we're also going to keep practicing. We're going to do more of these too. So hopefully by the end of it. If it is confusing, write down a question that you have about it. And it could be on this specific problem. You could say, hey, on the Chris parking lot question, why did you do this? Okay? Anything like that I can help you with. Let's look at another one. Daniel is setting up chairs for the 3rd grade play. There are 6 chairs in each row. There's 54 chairs in all. How many rows of chairs are there? Okay, so if he has 1, 2, 3, 4, 5, 6 in each row, and we have to figure out how many rows until he gets to 54 chairs in all. I want you to pause this video really quick, and I want you to try it on your own. Go. Okay, welcome back. Hopefully you actually paused it and tried it yourself. Okay, so if there's 54 chairs in all, I do know my total. Yes, do I know the total? Yes, he has 54 chairs, and I know that in all, that means total, right? So I start with my total when I'm dividing. 54 chairs divided into groups of 6, right? Will tell me how many groups there are, okay? I'm going to put C for chairs. For some of you that are more comfortable with multiplication, I could take both my factors, multiply them by each other, and get the total. So I could say 6 times something equals 54. Okay? You can sing your 6s. Okay? Hopefully you know that fact by now, but if you don't, you could do 6, and you could keep counting. Put 6 in each row until you get to 54. That's another strategy, okay? I'm not going to do it because it takes forever. But 6 times what equals 54? 6 times 9. Good. Okay. 6 times 9 equals 54. So that means there's 9 rows of chairs. So I would have to draw this 9 times, and I would get 54 chairs in all with rows of 6. try another one. There are 72 juice boxes for the third grade class party. The juice boxes are in packs of 8. How many packs of juice boxes are there? Okay, so if I wanted to draw a picture of this, actually I'm going to have you guys try it first. But think about, you could draw a picture if you needed to help you get started. Ask yourself, do I know the total? Okay, and what equation can I write to help me? Go ahead and pause the video. Go. All right, welcome back. Let's try it. Okay, so do I know the total? Yes, because it says that there's 72 juice boxes, and then they were broken up into groups of 8. So here's a group of 8. I got to keep going, right, until I get to 72. Here's the group of 8. Here's the group of 8, and I could keep going until I get to 72. Another way to do that is you could start with your total, 72 juice boxes divided into groups of 8. How many groups are there? Okay, 72 divided by 8. Again, like we talked about before, I could say 8 groups of juice boxes gives me 72 juice boxes in all. Okay, 8 times what equals 72? 9. 8 times 9 equals 72. I didn't mean to make all of these equal 9. Okay, J equals 9. So hopefully that was helpful to you. All right, let's look at what's next. Now we got a brain break. Okay, and this one's one of my favorites. Also, it's getting really dark. Turn on my light. Okay, hopefully that's better. All right, so for this brain break, we're going to tense and untense our muscles. So sit up in your chair wherever you're at, okay? And we're going to start at our toes, and I want you to squeeze your toes as tight as you can, okay? And then you're going to move up, and keeping your toes squeezed, you're going to squeeze your calves. Those are your lower legs. You're going to squeeze them. Now squeeze your thighs and your bottom. And then you're going to squeeze your fists. You're going to squeeze your back and your arms, and then squeeze your face, okay? And then you're going to slowly untense your muscles. So we're going to start at our face. Loosen your face. Loosen your shoulders, loosen your hands, loosen your thighs, untense your calves, and untense your toes and become jello in your chair. Okay, and then try it again, but start with your face. So tense your face up, tense your shoulders up, tense your arms, tense your fists, tense your thighs and your booty, tense your calves and your toes. And now we're going to release starting at our toes. Untense your toes. Relax your legs. Relax your hands, your arms, your shoulders, and become jello. Okay, so hopefully that helps. That's a good stress reliever if you guys are freaking out during a video. You could always do something like that. And then we can also try square breathing. Remember when we did that in class? So you started a square, and you're slowly breathing in. Remember, we're not gasping like we're dying or drowning, okay? We're just slowly breathing in. Okay, let's try it again. Okay, so hopefully that was a little bit of brain break. That'll help you. If you also need to pause the video, you always have that option. Okay, let's look at our next one. So we're going to kick it up a notch. We're going to try something new. Let's look at a different kind of word problem. So in the first ones, we were doing unknown factors. Remember, we were multiplying and we were dividing to find the answer. Now we're going to look at word problems with unknown starts, okay? And we're going to be doing addition and subtraction to find out what the total was. Or the addend. We'll have to look at the word problem. It depends on the word problem. Okay, so let's get started. All right. Oh, and review. Wait, how will I know the difference if I need to multiply or divide or add and subtract? And this is an awesome question. And we talked about it a lot in class, but I'm sure with the 2 weeks off, we forget these things. So you know you're going to be adding or subtracting in word problems when you're putting 2 different group sizes together, right? You're adding something together and you're finding the total. When you're taking something away or getting rid of something or losing something or anything like that, then you're subtracting, okay? You know you'll be multiplying and dividing when you're putting equal groups together. So equal groups means the same amount of something in each group. So we're multiplying when we're putting a whole bunch of groups together. 6 groups of 3, right? We're putting groups together. And we know that we're dividing when we have a total and we're breaking it apart into equal groups. We're saying there's the same amount in each group we're dividing, okay? The key that is with multiplication and division, you have equal groups. It's the same amount in each group. If you need to pause the video and read through that or take a second to re-listen to that, go ahead and do that. All right, let's start with some unknown starts. Dinah puts some beads on a string. Then she puts on 70 more beads. Now there are 130 beads on the string. How many beads did she put on the string to start? Okay, so since we're doing adding and subtracting, we can do math mountains again. Okay, so you're going to ask yourself, do I know the total in this problem? So I'm going to read through it again. Dido puts some beads on a string, then she puts on 70 more beads. Now there are 130 beads on the string. How many beads did she have to start? Do I know my total in this problem? Yes, I know that she has 130 beads now, right? So I'm going to put that at the top. She has 130, and then she had 70, and we don't know how many she started with, right? So I'm going to put B for beads. Okay, not sure of how many she started with. Now, just like in the lesson from the first lesson, we talked about if you know your total, but you're missing one of your add-ins, what do you have to do? You have to subtract, right? So we start with our total, 130. Oh, that's why I was trying to write 130 minus the 70 beads she put on later will give us what she started with, okay? Or another way I could write the problem is she started with some beads. She added 70 more, right? And she ended up with 130 in all, okay? So something plus 70 will give her 130. And I can flip that around. I can put my total first, minus those 70 will give me how many she started. Either way, whatever works best for you, okay? 130 minus 70. So I can count up from 70 till I get to 130, or I can think about it as 13 tens minus 7 tens, or I could write it like this, whatever works best for you. Okay, I'm going to count up 70, 80, 90, 100, 110, 120, 130, and I get 60. Oops, there we go. 60 beads is what she started with. Okay. All right. Make sure you pause it. If you have any questions on that, write them down. We'll go on to the next one. Okay, so this one's with Dido too. We're going to look at this one. Dido put some beads on a string. So again, we don't know what she started with. 70 of the beads fall off. Now there are only 60 beads left on the string. How many beads were there at first? Okay, so if I've got my math mountain, I ask myself, do I know the total? Something that might be tricky for some of you, so maybe we could even write an equation exactly as how it happens, right? So she puts, remember we call those situation equations, so writing exactly what's happening in the problem. She has some beads, so I'm going to put B because I don't know how many beads that is. 70 of them fall off. So we ask ourselves, am I adding 70 beads or am I subtracting 70 beads? I'm subtracting, right? Because they fell off. I got rid of them. And I ended up with 60 beads. Now let's ask ourselves, do I know the total in this problem? No, right? I don't know the total amount of beads that she started with. Or that was all. Then I know that I lost 70 and had 60 left over. Okay, another way to write this equation is I could say addend plus addend will give me the total. The 70 beads that fell off plus the 60 beads that were that were still on there will give me the total amount of beads that she started with. 70 plus 60. The way I think about it is 70, I could take 10 off and make it 60. 60 plus 60 is a double, and I know that's 120. And then I just have to add that 10 back on. 120 plus 10 is 130. Okay? You could also think of it as 7 tens plus 6 tens. 7 plus 6 is 13, but it's 13 tens, so I add the 0 on it. 130 beads. So the difference between this problem and the last problem is we did know our total, right? She got 70 more beads and then we knew our total. This one, we didn't know our total, so we had to add together to find the total. Okay, let's look at another one. Angel was carrying some papers for his mom. His mom asked him to carry 30 more pieces of paper. Now Angel has 110 pieces of paper. How many pieces of paper did he start with? Okay, so if I write another situational equation or an equation that is happening, or that's exactly what's happening in the story, I would say he's carrying some papers. Do I know how many papers he's carrying? No. So I'm going to put a P for papers. Okay, his mom asked him to carry 30 more pieces. So she gave him 30 more pieces to carry. So we're adding on 30 more. Oops, I forgot I was going to have you pause the video here. We'll just work through it. Or if you want to pause it right now, go ahead and try it. 30, and then Angel has 110 pieces in all. So I do know my total on this one. Okay, so if I draw my math mountain, I've got 110 pieces in all. 30 pieces that his mom gave him, but I don't know how many he started with. Okay, that's one way to write it. I could also write it with my total minus one of my add-ins will give me the other add-ins. Okay, give me the other add-ins, sorry. All right, 110 minus 30. I'm going to count backwards from 110. 30 by tens till I get 30. Okay, 110, 100, 90, 80. Okay, so I know my answer is 80. He started with 80 pieces of paper. His mom gave him 30 more. So I can put 80 right here. And he ended up with 110 pieces of paper. Okay, let's look at the next one. Angel was carrying some papers for his mom. His mom took 30 pieces of paper. Now he has 80 pieces of paper. How many pieces of paper did he have at first? Go ahead and pause the video. Try this one on your own. Go. Okay, welcome back. Let's try it. So Angel was carrying some papers for his mom. I'm going to put P for papers. His mom took 30 pieces. The word took tells me that we're subtracting, right? We're getting rid of something. And then he ended up with 80 pieces of paper. Okay. Do I know my total in this problem? No. So if I drew my math mountain, I don't know what my total is. I know that his mom took 30 and he had 80 left. If I know both of my add-ins, how will I find my total? I need to add them together, right? 30 plus the 80 that he had will give me my total. 80 plus 30, I'm just going to count on 80, 90, 100, 110. Okay, 110 pieces of paper to start with. Okay, so hopefully those were helpful to you. All right, so that ends our lesson for today. So after this video, you're going to go do some on your own in the practice. If you click on that link, you have to fill out the practice ones. Also remember at the bottom of it, you can type in any questions or any feedback you had on the video, okay? So by the end of this lesson, I can solve word problems with unknown factors, which we did at the beginning when we were multiplying, and word problems with unknown starts, which is what we were just doing with adding and subtracting. Again, make sure you let me know if you have any questions or if there was anything you need help with. I'll check your scores on your thing to make sure that you understand the concept or if you need more practice with it. Hope you have a great day. Thanks.